1.4 is our lesson today, and here's our learning goal. I can solve equations in one variable, so again, there's only one variable involved in it, that contain more than one operation. So in other words, notice they're no longer one-step equations. It's going to take more than one step of work, and you need to show those steps of work in your process of solving problems. So let's give a title here. Lesson 1.4, so you know in your notebook what this is about. And it is solving, we're going to call it solving multi-step equations. Lesson 1.4, solving multi-step equations. And I like to practice some of these with you instead of having you just do this on your own, because when you get to you have to do more than one operation, you actually have more than one option. But what you need to become are good students of what's going to create more work for me, what's going to make it harder for me, versus what's going to make it less work for me. So I'm guessing that you're all into having less work involved, right? And so let's make this little statement to start with. Usually, okay? This is just not saying you have to do it this way, but usually better to undo addition or subtraction first. So I'll put that there, let you catch up. Usually better to undo addition or subtraction first before multiplication. What's this? Let me get ready to spell that wrong here. Multiplication or division. And I'm going to show you a problem. We're going to do it both ways, and then you'll see why I make this statement. Usually better to undo addition or subtraction first before multiplication or division. Now, remember, in order of operations, when we're evaluating an expression, what comes first? Does addition and subtraction come before multiplication and division? No. In order of operations, we say parentheses, exponents, multiplication and division from left to right, addition, subtraction from left to right. In order of operation, we take care of multiplication and division first. We're going to do the reverse of that when we're undoing, because that's kind of what inverse does. We do the reverse. So let's just do a problem right away. Let's solve this equation. -4 plus 7x equals 3. So let's solve that both ways, okay? Let's do it two ways. Let's do it the way that I just said. Usually it's better to undo the addition or subtraction first. So what would we do to this one then? We're going to undo the addition or subtraction first. Sage? We would add 4 to both sides, because we can read addition backwards. This really says 7x plus a -4, and we learned back in lesson 1.2, or hopefully you learned, that when a negative number is being added, we're going to add its opposite to undo it. So we add the 4 to both sides, and now we have 7x alone and 7 on the other side. And then, of course, what will we do next? Divide by 7. Okay? So we'll take that 7x, we'll divide it by 7, we'll take the 7, divide it by 7, and we find out that presto, the answer is x equals 1. Yeah, x equals 1. Okay, that was pretty harmless, pretty pain-free, wasn't it? Anybody have any questions? Okay, well, now let's do it the other way, okay? Let's do it, let's say if you want to undo the multiplication first, You can write that out like this because it's very important that we understand that, you know what, it's okay. If you decide that you want to undo the multiplication first, you can. It's okay. Lightning is not going to come down and strike you. So let's write our equation again. It was negative, I already forgot, negative 4 plus 7x equals 3. So you say to yourself, you know what? X is being multiplied by 7, so I'm going to undo that multiplication. I'm going to divide by 7. What gets divided by 7 then? John? Negative 4 and 3 and 7x. All parts have to be divided. All parts have to be divided. Whenever you're going to undo multiplication or division first, you have to make sure that you do it to every part. So here's what we would have to do. And go ahead and do it with me so you can have the fun of seeing, you know what, when should I make good decisions? We're going to divide every piece by 7 because that's legally what you would have to do. And I want everybody to do it with me because I want you to have the fun of it. Huh. Do you like negative 4 divided by 7? No. What is that? Is it a nice decimal? No, it's a repeating decimal. What do we do when they're repeating decimals? We leave them as fractions. So that negative that's up there with the 4 can come out front and say this is negative 4/7, right? These guys cancel, so we have our x alone now. I mean, it's a 1x, it's not alone yet, it's a 1x. And how about 3 divided by 7? Is that nice? No, so we're going to leave it as 3/7. Okay? So, everybody still with me? What do we do next? Add negative 4/7?
Yep.
No, we add the opposite of negative 4/7, which is positive 4/7. So we're going to add 4/7 to both sides. By the way, when you add or subtract, you only do that once on each side. Silly as it is, but that's how it is. And then we say, okay, well now the x is all by itself. And we have common denominators. That's cool, because if there are common denominators with fractions, then we can add their numerators together. 3 plus 4 is 7. So we have 7 over 7, which is 1. We get the same solution. Which one do you want to do? First one? Yeah, me too. So what we did the second time was not wrong, but did we create more work for ourselves?
Yes.
We sure did. So, you know, we gotta become, good algebra students and say, you know what? I know if I do it this way, it's going to be less painful than if I do it that way, because we can't make up our own ways. So, any questions? Okay, I'm going to give you one to solve on your own now. Then. So let me get it so I have enough paper here. So solve the following. I want you to solve a decimal one. Okay, and you decide how you're going to solve it. Go ahead and do it. And remember, our goal is to try not to use our calculators because we're so good like that. We're not going to have machine brains. We're going to start getting our muscles developed in our brain. Some of you might now be starting to get into that panic mode, like, oh, seriously, I don't know what 7.2 divided by 1.2 is. Does anybody at that stage here? Huh. What happens when you divide with decimals? What can you do? You can multiply, in this case we can multiply by 10, in other words, the upstairs and the downstairs. We could rename that. We could just go like this. It wouldn't hurt it at all. We're going to get the same thing. We could say, oh, you know what? Let's move each over one. So really what we have is 72 divided by 12. We just renamed it. What is 72 divided by 12? Anyone happen to know in here? 6, yeah. These cancel. And there's our solution. Looking at this one, how much fun do you think this one would have been to divide first? Would you like to have divided 1.5 by 1.2?
No, thank you.
No. How about 5.7 by 1.2?
No.
Not so friendly either. And this wasn't very bad at all, was it? So again, usually it's better to undo the addition or subtraction first and then go back and do the multiplication or division that needs undoing. Okay, let's move on and do one with fractions. I know how you guys love fractions. Am I right? Show of hands, love of fractions. Got a couple of brave souls. Okay, solve. Plus, I gotta show you that we can't just, pretend that we're doing it without the calculator, because if we do, then we're oopsie, I didn't mean 4/8, I meant 1/2. That's better than that. That's not simplified. 1/2 equals 7/8. When I see a problem with fractions, the first thing I evaluate, before I even go on, is I like to say, what operations am I going to have to do in this problem to get that A alone? What's one of the things I'm going to have to do? It's one of the operations I'm going to have to perform here. You're already doing it, really. Come on, talk to me. What would be the first thing we do here in this problem, especially this time? Subtract 1/2. Well, if we're going to have to subtract 1/2 from both sides, on the other side, are they halves? No. So what do you think we should do with this equation before we even start? Judd?
Switch them all to the same amount of denominator.
Yeah, let's rename this equation so they all are what? What denominator do you want to use? Eighths. Okay, so 3/4 is what in eighths? 6/8. Okay, so we'll just rename that. That's all we're going to do right now. And then we have 1/2, which is 4/8. And that 7/8 doesn't have to change. Now it looks a lot friendlier because all of them have eighths they're in their denominator. Now we can go to work. We're going to subtract 4/8 from both sides. When we add or subtract, we just do it once on each side. And now we have 6/8 A equal to 7/8 take away 4/8. 3/8. Okay. Now we're going to do what? Divide by 6/8. But divided by 6/8 is really the same as, we don't even need to show this step. We can just go right to multiplying by 8/6. So we're going to multiply both sides times 8/6. And because again our goal is not to use a calculator, so these 8's cancel, these 6's cancel. We have an A all by itself. These 8's cancel. And we have what? 3/6, which is 2, right? No. What is it? 1/2. There's our answer. I did that because there were lots of people about last week that said 5/10 was 2. And we gotta be careful about that, don't we? So 1/2 is our solution. Okay, now I need your books open to page 35. Page 35. Your textbook. We're still working on the notes. We have one more problem to do. We're going to do a word problem because I'm just not sure the effort is really good enough there on these word problems, and I think part of it is because you just don't know what to do. So I want you to put in your notes that we're going to be doing the check it out problem. And it's about mid page 35. Okay, about the middle of page 35 is where we're going to find this problem. And it's problem number 4. Okay. So I need you to read that problem about Sarah to yourself. Here's what we're going to start doing that we haven't done yet. I haven't seen this on paper. We're always going to identify what variable we're going to use and what to represent it before we even set up the equation. We're going to write that on our papers. So, can somebody tell me what the unknown is that we're solving for in here and what variable you would like to pick for it? Tyler, what do you want? It's the monthly fee that we don't know. And what variable should we use? You get to pick. Pick a variable, or did they pick it for us? I don't think they did, or did they? M? You want it to be M for month? Okay. M is the monthly fee. You write that down. And when you do word problems, this is my expectation. You tell me what is your variable representing in that equation that you're going to set up. So M is the monthly fee. Okay, who wants to offer up an equation that they think would represent this problem? John?
15, 95 plus 12 is equal to 735.95.
How much? $735.95, okay. Okay, how many of you think that's a good equation? Takers, okay. The $15.95 must be a one-time fee, is that right? Okay. The 12 tells me that it must be 12 months, not $12, because M is the amount per month. So it must have been for 12 months. Am I right? Okay, and altogether this person must have spent $735.95. Okay, cool. Solve that equation to see how many months this person, Sarah, or not how many months, the monthly fee that Sarah was paying. Go ahead, solve this equation on your papers, in your notes. You don't need a calculator, this is actually pretty friendly. Actually, considering we just did something with these numbers. Pretty sure we just had a 72 divided by 12. What did we say that was? 6. But then we got that 0 behind that 72, so it's not 6, but it's 60. So M equals 60. And just by looking up at what we said the monthly fee, what the variables represent, it says the monthly fee, we know what our label is. What's our label? Dollars. Yeah. $60. Okay? So, anybody got concerns about that? So what is my expectation for word problems? This. When it says write and solve an equation, this is what we're going to do. We're going to pick our variable and describe it. We're going to write our equation with our variable in it. We're going to show our work solving it. And when we get our answer, we're going to give it a label. Okay, so can you do that? Okay, any concerns, questions? Okay, go ahead and get out a sheet of loose leaf paper. You can put your heading on. Do I have anyone who needs the notes up here any longer?